The following information is given in connection with the figure below. VA is equal to 120 volts, VB is 105 volts, R1 and R2 is 1.5 ohms, R2 is equal to 3 ohms, RA is 21 ohms, and RB is 6 ohms. Calculate the loop currents I1, I2, and I3, the load currents IA and IB, and the load powers PA and PB using mesh method. So now that we are done using Kirchhoff's laws in the previous examples, we are now going to use Maxwell's mesh method. So the sign we'll write will be the polarity of the element we are entering. In this example, we have 3 meshes and we'll name them I1, I2, and I3. And for convenience, we'll have them directed in a clockwise direction. Before writing our equations, let's go ahead and label the polarities of each of the components. And don't worry, you don't have to overthink. It doesn't really matter where the current is flowing for now. We'll figure that out later. As long as we follow the correct sign conventions, we'll be good to go. Okay, so let's start working on the first mesh, I1. In this mesh, we have 3 components, and let's start off with the voltage source, which will be negative because we are entering on the negative side, plus next we have I1R1 with a positive since we are entering the positive side, plus, and for this resistor we can see that 2 currents are involved, I1 flowing downwards and I2 flowing upwards. And so the net current will simply be I1 minus I2 because both of them are flowing in the opposite direction. And this is multiplied by RA, all equal to 0. Next, let's go ahead and substitute what we know. We'll do a couple of simplifications and combining like terms. And therefore, we'll have this as our first equation. For the second mesh, again, we'll follow along in the clockwise direction and with 3 components, starting off with this resistor. Again, this one has 2 currents involved, so this will be I2 minus I1 multiplied by RA plus. Next, we have this resistor I2R2 with a positive sign plus. Same process with RA. We'll write I2 minus I3 multiplied by RB all equal to 0. Now we'll substitute what we know, simplify, and we'll get this as our second equation. Lastly, for the third mesh, let's start off again with RB. So we have I3 minus I2 multiplied by RB plus I3R3 with a positive sign plus VB also with a positive sign, all equal to 0. Again, substitute the given parameters and simplify. And so now this will be our third equation. At this point, you can use any algebraic method you want to find the unknowns. And if we plug this in a matrix, we'll get I1 is equal to 10 amps, I2 is equal to 5 amps, and I3 is equal to negative 10 amps. This negative sign only tells us that this current is actually flowing the other way around. Now for letter B, we are asked to look for the load currents IA and IB. As we look at RA, we can observe that 2 currents are involved in this resistor, and that is I1 minus I2. I1 is 10 amps and I2 is 5 amps, and so we'll get 5 amps. Now for IB, this resistor also has 2 currents that are flowing opposite with each other. Therefore, IB is equal to I2 minus I3. I2 is 5 amps and I3 is negative 10, and so we have 15 amps. Lastly, for letter C, we have to find the load powers PA and PB. The power formula we'll use will be P is equal to I squared times R. For resistor A, we have IA as 5 squared times 21, which is equal to 525 watts. For resistor B, we have IB as 15 squared times 6, and this is equal to 1350 watts.